Hello, physics students. Miss Feck here, and today we are starting Unit 7, which is all about electrostatics. Please make sure you have a pencil and paper out. I suggest taking notes throughout this video on any definitions you see, things that you think are important, or if I stop and ask you a question that is probably good information that you will then want to have access to when you are doing the IP as well as the quizzes. Without anything else, we're going to get started. What do you know about an atom? Have you heard the word atom before? An atom is the smallest unit of matter, and it makes up everything all around us. You've probably heard this corny joke before, but here it is again. Never trust an atom because they make up everything. It's important to have a basic understanding of the history of the atom, and we're going to go through this pretty fast. But back in 460 BC, Democritus pounded down materials very, very small and came up with what he called the atoma. Then John Dalton came around many, many years later in 1808 and suggested that all matter was made of tiny spheres, which he called the atom. And then J.J. Thomson came in 1904 and he started to look at the plum pudding model, realizing there was both negative and positively charged parts of the atom and negative electrons all around, and then a universal, the whole thing was positively charged. And then came Rutherford in 1910 and he started to realize, okay, the center of this atom is positively charged and there's negative charges around it. So becoming a little bit more specific through different experiments. And then through the nuclear model, we start to see electrons moving around. And Niels Bohr came up with what we use a lot today, which is called the Bohr model, in which the protons are in the middle of this atom called the nucleus, and then electrons are all around it, spaced out in different orbits, and they orbit the nucleus just like the planets orbit the sun. And then Chadwick came around and discovered neutrons, which have no charge. They have a neutral charge, neutrons, and they are also found in the center of the atom in the nucleus, and they add mass to this atom. And then came around Gell-Mann in 1964, and he talked about quarks, which are the smallest known particles, and these group of three make up protons and neutrons, and they occur, the up and down occurred naturally. Here's a short, small little timeline of the history of the atom. And the most important thing to see here is notice that scientists use each other's information to further the explanation and make even more discoveries. So 1930 really was not that long ago, as well as quarks in 1964. So this is, science that is ever changing and really impacting everything that we talk about today in science. And you will go into greater depth over the history of the atom in chemistry, as well as the experiments that help scientists figure out what is going on with each of these pictures. So if you take chemistry, that is something to look forward to. Today, like I said, we are going to be focused on the atom specifically. This is one picture of an atom, specifically one atom of helium. Notice that in the center, this is our nucleus, what I just circled there. And our nucleus, if I can spell it, our nucleus contains both protons and neutrons. The protons are those positive arrows. The neutrons just have mass and have no charge in the middle. Then the electrons are on the orbits in the shells. And notice that the electrons are as far away as possible because likes repel each other. So kind of like if you had two magnets, both north ends together, they repel each other, very similar to negative charges repel each other. So they're as far away as possible on those orbitals as possible. This is really great information. I suggest copying this down. This helps us walk through all the important information of our particles, the protons, neutrons, and electrons. So if we start by looking at the protons, we can see the protons we can write as P plus, and you will see that oftentimes as shorthand to help save time. And our protons have a positive charge and have a mass of 1 atomic mass unit. Our neutrons are named N with a little O representing no charge. Like we said, no charge, but they do have mass. And then our electrons you'll see as E minus, as a -1 charge, and then they are very small. So for the sake of this class, we'll just assume that it's 0. So if there's electrons present, they're taking up no mass. It's so small, it's negligible. If an atom is neutral, the protons will be the same as the electrons. So if I had 5 protons and 5 electrons, that would be like saying I have 5 plus and 5 minus. Well, if I were to add those together, that will give me 0. So similarly, 5 protons and 5 electrons would give me no charge. So therefore, for any of these, if they're neutral, the protons equal the electrons. A little more in depth about electrons. They are arranged in shells around the nucleus of an atom, just like you see here. The first shell right here, closest to the nucleus, can only have 2 electrons. So I start by putting those 2 electrons there. In this atom, I'm going to have 7 electrons because it is neutral. So the number of protons equals the number of electrons. And since I see I have 7 protons, I will then have my 7 electrons. So I start by placing electrons closest to the nucleus. I place 2, go to the next shell. Well, I have 5 more to place. I place those in the second shell, and that second shell can have a maximum of 8 electrons. And then if I had an even bigger atom, the third shell could have 18 electrons. So again, I fill the orbits or the shells closest to the nucleus first, not exceeding that maximum number of electrons. You have likely seen the periodic table of elements before. You will not need to memorize this, but you will need to be able to look at this periodic table of elements and read it and determine the important information from there. We're going to start by looking at sodium. I'm going to ask you some questions about sodium. So I need to find this element on the periodic table of elements, which sodium is right here. And we'll take a look. What do each of those letters mean as well as the numbers? So the sodium we see here, the atomic number is 11. That number up here is always the atomic number. Right here we have the element symbol, so a little shorthand. We have our element name, and then we have our average atomic mass. Well, what do these numbers mean? Our atomic number is the number of protons in an atom, so that is always equal to the number of protons. And then our electrons, like we just said, will be the same as the protons. So for example, this one, the atomic number is 11, which is equal to 11 protons. So then I will have 11 electrons as well because it's neutral. Then the atomic mass is the number of protons and neutrons in an atom. So I like to write a little formula to help remind me. My protons and neutrons give us all the mass present in the atom. And we are always going to round this to the nearest whole number. You need to round it when it's asking you for the mass number. Now, the reason why we have a decimal place is because we actually, this number right here is actually the average of the atomic mass from the isotopes. So we have different atoms of hydrogen that each have a different mass. Then we can take the average to find the average atomic mass. But in this class, we won't get too much into that. You will just need to round that average atomic mass to the nearest whole number to find the mass number. Now, if we look at hydrogen here, just a little bit of practice, the atomic number can be found here. So it has an atomic number of 1, which right away I'm thinking atomic number is the same as protons. So therefore, I have 1 proton. And then I can even also think, since this is neutral, therefore, number of protons equals the number of electrons. So therefore, I have 1 electron. The atomic mass is found right there, but I need to round that to the nearest whole number. So rounding that will give me 1. And then the number of neutrons, let me think. So nothing on here gives me the number of neutrons. However, I can look at the formula we said before, which is atomic mass equals protons plus neutrons. Therefore, neutrons will give me, I can find neutrons by doing atomic mass or mass number minus protons. So in this case, the mass is 1. I have 1 proton. So how many neutrons do I have? 0. Now let's look at argon. Answer these questions for a check for understanding. First, I find argon on the periodic table of elements. It is right here. And I can look at the information from here. This, of course, is my atomic number, which is equal to my number of protons, which is equal to my number of electrons, because it is neutral. My mass number I get from here, but I have to round it to 40. So then, in order to get my number of neutrons, that will be atomic mass minus atomic number. So I'm going to do 40 minus 18, and that will give me 22 neutrons. Thanks for tuning in. Make sure that you do your IEP and that you're ready for your quiz next class. Email your teacher if you have any questions.